So now a couple of videos ago, I looked at using a single LED as a mini solar cell. So really it can provide practically no power, but using an amplifier, an op amp here, we're going to use the LM358. There's two of them on the integrated circuit. We're only going to use one, and we're going to power it with 5 volts. But in case, when you connect the output directly to the inverting input, I have a little jumper that's going to do that, a direct connection. Then whatever voltage you apply to the non-inverting input will be the output voltage there. And the op amp can power stuff at that voltage. This is just telling it what voltage to apply at the output, and the op amp will provide as much power as it can within limits, of course. But it'll be plenty for this video. We're just going to measure with an oscilloscope the voltage at the output, since it will be the same as the voltage at the non-inverting input because of the negative feedback. That's how we'll know the voltage there. Because my oscilloscope doesn't have enough impedance, enough resistance, it lets too much current go through it for an LED to build it up. Maybe 3 of them. So we got 3 in series. We'll get 3 times the voltage. And then there's 2 parallel here. So we should get twice the current as well. And I meant to actually connect them between there, but really it shouldn't make too much difference. But on the board they are connected also there. But in any case, we need the resistor because the voltage will build up. They'll build up a voltage at the non-inverting input, the LEDs, but not let it go back down. It'll build up a little charge there and hold it. So we got the resistor to help bring it down when we drop light on there. So 10 million ohm resistor, pretty high value resistor right there. That's what I needed to make this circuit work. Now we have the capacitor here for a couple of reasons. One, with the lights I'm using, at least we're getting a very steady, very unsteady voltage with just the resistor. So the capacitor will smooth that out. And also it's kind of cool. It takes a little more time for the voltage to change. So you get a nice curve instead of the voltage jumping around as the jumping more rigidly as light falls on the LEDs. So it's 10 nanofarad, pretty small value capacitor, but works pretty nicely in the circuit, as we will see. So here you can see, first off, we got to power it. So that's pin 8 right there, even though 8's not written on there, the positive supply. Pin number 4 is the negative supply, which is ground. This is a single supply op amp. We have 5 volts at the rail there, positive and negative. So that goes to ground. Now, the output, that is pin number 1, top left pin. Here's another op amp. We could use that one instead, but we're going to use this one over here. So pin number 1, top pin, there's a little jumper right there, just in case for some reason you can't see it. You should be able to see it now. It's just a bare piece of metal right there. Going down one more spot to the inverting input. And then right below that is the non-inverting input, the plus. When you're looking at these schematic diagrams, make sure you pay close attention to where the plus and minus is. So it's always output minus plus on the LM358. But on the schematic, they may put the plus on top and the minus on bottom. You got to make sure that whichever spot the plus is, it goes to that pin there, pin 3. Wherever minus is, top or bottom, you got to connect it to pin 2, whatever is shown on the schematic. They do line up though in this schematic, and so it's not a problem. Now we got the 10 million ohm resistor and the 10 nanofarad capacitor. So nanofarad is 1/billionth of a farad, very small. And most of my videos I use microfarads, which are thousands of 1,000 times as many as nanofarad. And doesn't want to slide up right now. So there we go. So you can see that we got the capacitor there. It's pretty small. So at the non-inverting input and ground right there, and then the 10 million ohm resistor right there. So this jumper goes to the power supply, and then we got the LEDs. So there you can see how they are on the schematic. We're kind of running out of space here, so I'll just zoom in. You can see that we got 2 down here. So that's the cathode, the short lead, to ground. Long lead, the anode of all of these are above their cathodes. And then we got 2 more on the next row, even though they're kind of hard to see. And then 2 more, and the 2 on top here, they're long leads, their anodes go to that white jumper. Let's see if I can space that out right there. So the long leads of those 2 going to that white jumper to the non-inverting input. And finally, we got the pocket oscilloscope hooked up. The voltage we're looking at is in relationship to ground, because that's where the negative side, the cathodes of the LEDs come. We got a jumper to the output, and I got a resistor right there. First off though, I'll cover the LEDs with my thumb right there, and you can see the voltage dip down. It's taking time because of the capacitor. Now I released it, and it's going back up right there. So that's not as impressive as what we'll see now, but we can, you know, get a little bit of voltage there. And so I'm going to grab my headlamp here, which is pretty bright because my flashlight's not working too well. But in any case, there you can see we got a voltage change and the red LED lit up. If I remove this, you can see the LED fades off as the voltage goes down there. So if you remember, or if you saw the other video, we got about 1 and maybe 1.2 volts, I should say, with just one LED with pretty close to this same setup. And so when we got 3 in series, now we're getting about 3 times the voltage. And if I remove 3 of them, we should probably get a voltage change that takes about 3 times as long, because we got about 1/3 of the current. We had a spike there for some reason. I probably shorted something out. But any case, let's take a quick look at that. So that's about how quick I put the light there. And I think it may have took a little bit longer. But any case, it's not going to make a huge difference in this particular circuit. But I think it did. So any case, fun little experiments to do with common components right here using the LEDs. They're acting like little solar cells. They are creating a very small amount of power when light falls on them. Not efficient at all. You would definitely, if you need solar power, you should definitely use an actual solar cell, but you can still play around with these, do some interesting things. Also, some circuits, you may have a problem with the diode. Light falling on it, it's building up a voltage that is messing something up because it's a sensitive circuit. So you may have a point in time where you can troubleshoot a problem with light falling on a diode, like an LED. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. If you can donate, please do. I have links down below. But otherwise, I appreciate you watching the videos. Thanks for that. I'll see you in the next video.